We're going to be talking about diffusion, okay? We're also going to be talking about active transport in a little bit. But let's start with diffusion. Diffusion is passive. If something is passive, it is not using energy. What is the currency for energy in the body? ATP, exactly. And it goes from a high concentration to a low concentration. My example for this, if you have a hill, pretend this is like a hill, and you have a ball. This is high, and obviously down here this is low. If it rolls down the hill, right, do you have to use any energy? No, because gravity takes care of that, right? So you go from a high concentration to a low concentration. And you're going down the gradient, which means you're rolling the ball down the hill. So that's like passive diffusion, which is a type of passive transport. Okay. Now, if we look at the number of solutes here, right? Where is there a high concentration? Outside of the cell or inside of the cell?
Inside.
Inside. So we're going from a high concentration to a low concentration when we're talking about diffusion, right? Mm-hmm. So where am I going to draw an arrow? From a high to low, which would be going inside or outside?
Outside.
Outside, exactly. Most people have trouble understanding this, but you guys got it fairly quickly. Okay, from a high concentration to a low concentration, so that we can have equilibrium. What is equilibrium? When we have equal amounts of these solutes inside and outside. Okay, because we don't want all of them to go out. We don't want them all to come in. We want equal amounts, which is equilibrium. Okay, perfect. So with diffusion, especially simple diffusion, there are certain molecules that can go in and outside the cell, such as things that are small and nonpolar. Remember that. Small and nonpolar. Okay, for simple diffusion. So a subcategory of diffusion is facilitated diffusion. The word facilitated means that it has an helper. What is an example of a type of helper? Well, that would be the protein carrier. Where is the protein carrier found? On the plasma membrane. Okay. It pretty much acts like a bouncer. If someone's getting kicked out of the club, the bouncer will help that molecule to leave or enter the cell. It depends on the concentration gradient. So basically, facilitated diffusion is still passive, no energy is used, high to low, and down gradient. Why are all these things there? Because it's a type of diffusion. What's the only difference between facilitated diffusion and simple diffusion? The use of what?
Energy?
What are these bouncers called?
Oh.
What kind of carriers? Protein or carbohydrate? Protein carriers. Now we're going to talk about osmosis. Osmosis is passive, right? What do we know about being passive? Are you using energy or not using energy? Not using any energy, right? So that means you're still going to go from a high to low. You're going to go down the gradient. And with osmosis, what are we thinking about? Something that we drink, osmosis. Huh? Water, H2O, exactly. So the difference here is that the molecule that is moving is not like a regular solid. What is moving? Because we're thinking about osmosis, water. So it goes from a high water concentration to a low water concentration. Okay, from high to low. Notice I have how many H2Os here? Three. How many H2Os do I have here? One. So high to low for water. Okay, for osmosis. So now we're going to be talking about the opposite type of transport. We first talked about passive transport. Active transport uses energy. That's why it actively is participating in the transport. It goes from a low to high concentration. What does that mean? Well, in my last example, I used a ball rolling up a hill, or rolling down a hill. This time it's rolling up the hill from a low concentration to a high concentration, okay? And you're going against the gradient. So we have a higher concentration inside, we have a low concentration outside, right? So where will the solutes go, or where will these molecules go?
Inside.
It would go inside. Why? Because it's going from a low concentration to a high concentration. How do we know it's low? Because it has a low number, it only has 2. How do we know this is high? Because it has a high number, which is like 6 circles. Okay. What's a primary example of this type of transport in the body? Well, that would be the sodium-potassium pump. You guys don't know about that yet, but you will need to know that later in your profession. So with the sodium-potassium pump, we have 3 sodiums being pumped out for every 2 potassiums that are pumped in. Okay? So overall, if I have 3 people leaving the club, for every 2 that comes in, what happens to the club? Does it become more empty or full?
Empty.
Empty, right? So 3 people leave, 2 people come in. Like, you lost 1 every time that happens, right? So what happens to the charge inside of the cell? Since it's becoming empty, is it getting more negative or more positive?
Negative.
Negative, exactly. So that's the whole purpose of this sodium-potassium pump, okay? So with active transport, we also have these protein carriers, which assist molecules to either leave or enter the cell. Okay? Where are the protein carriers found? On the what membrane?
Plasma.
Plasma membrane.